months, the final one. But right now, they want to let the people that got delayed do it first.
Okay. All right. Okay. So let me search for the book. Okay, we were doing this. We were doing this cumulative frequency
Yeah.
diagram stuff. Okay, let me search for. So, do you buy the basic theory textbook and the final theory textbook?
No, not yet.
Oh, okay. All right. That is yeah. Here, question 14. Oh no, chapter 14. Okay, we're here. Okay, we talk about variance and standard deviation. Okay, and we know that standard deviation is a better measure of the dispersion of the data, right?
Yeah.
So all right, so let's start from here. So over here, what it says is like we're sampling from a population. Oh, we just had an election. Do you know that?
Yeah.
And so
It doesn't really matter. It doesn't really matter. It's the same dudes.
wait. I think the popularity of the PA.
Yeah, the popularity changed. I think the Workers' Party got a bit more, but it's still the PAP.
Yeah. So PAP got what they wanted, majority, but this majority decline quite significantly from the past election. I think about 10 percentage point, and I mean 10 percentage. Yeah, from 71% in the last reset election to 61%. You know, their all-time low is slightly below 60%. So right now they are like close to the all-time low.
Yeah.
Yeah. Okay. All right. So I think you have heard about the sample counts, right? During the vote count, right? So what they do is instead of counting every single vote, so they just pick a random sample, and then they try to get the result from this sample count.
Yeah.
And this result from the sample count is plus minus 4%. Okay, within this plus and minus 4% points compared to the result that you will get if you do count every vote. All right. So over here we're also talking about the sampling from a population. So in this so from here onwards, right? You know, when we do statistics on a population, I think it's pretty hard because you need to do the census diligently. So it's pretty hard to get data from the entire population. That's why I think it's good to use this sampling from a population and do the statistics from there. All right. So this sampling from a population is less vigorous, and the accuracy is plus minus a few percentage point from the main one. So I think this is good enough sometimes. All right. So over here, if you look at this, the mean, look at the symbol here. So the mean for the sample is actually denoted by this something x, and over here for the population is called mu, right? And the variance is Sn square, and for the population is rho square. And over here, standard deviation is Sn, and for the population is rho. So I hope you can see that variance is just square of
square the deviation.
Yeah. All right. So given this, so over here it says, however, given statistic from a sample, we can make inference. Yeah. So this is the word. Okay. We can make inferences. Okay. From this small sample, and try to infer from this small sample and talk about how it will look like for the entire population, right?
Yeah.
So note on parameters and statistics. A parameter is a numerical characteristic of a population. A statistic is a numerical characteristic of a sample. So we talk about statistics here. So we talk about a sample mainly, okay? But if we want to talk about a population, that is a much larger data set. So it is called parameter, all right? All right, so if you look at this, a random sample of 48 sheep was taken from a flock of over 2,000 sheep. So you just take this 48 sheep as a sample. So this sample mean of their weights was this with variance this. So find the standard deviation of the sample. So standard deviation is square root the variance, right? Over here.
Yeah.
Let me just grab it out. All right, so just let me get my writing pad ready as well. All right, so this is the variance, right? So to find the standard deviation, okay, to find the standard deviation, so we just need to square root this, right? So can you see?
Yeah.
All right, and hence estimate the standard deviation of the population from which the sample was taken. So we can actually estimate it to be this. Okay.
Okay.
So basically, we use the sample statistics to estimate. So estimate the parameters of the population. Right? Sample to estimate population. Okay, so find the unbiased estimate of the mean weight of the sheep in the flock. So the mean is this, right? Given by this, right?
Yeah.
Yeah. So basically over here it talks about we use the sample statistic to estimate the population parameter. All right. So all right. So over here, so standard deviation for group data. Okay. So standard deviation for group data is this is the way to do it. All right, manually. All right. So this is the formula. Okay. So let me just this formula looks really complicated, but let me just untangle each of these terms here so that you really know what it means. All right. Okay. So let me just take this as an example. Okay. So this is the example. So it's always good to establish a table to do this question. Let me just do it here because over here I can create more table. So you are asked to find the standard deviation of the distribution. Of course, the fastest way to do it is you can use your calculator, or you can also use Excel, right? You just type equal STD EV, you immediately will get the standard deviation, right? But what if you don't have that available? You don't have that at hand, so you have to do it manually. So let me just grab this formula to showcase to you how you can actually use the formula to solve this simple question. So this is the formula. Okay, so let me create a table from this table. Right, I like to do it vertically, right? So let me just recreate this table into a vertical table.
Yeah.
So this is the frequency. So you have 1, 2, 4, 2, 1. All right. So in fact, your score is actually denoted by your X. Okay. So this is your frequency column, right? So first thing first. This is your sigma sigma of each of this. Okay, and then this is your sigma fi. So what it means? Okay, let's do this part first. Okay, let's do this part, the denominator part first. So the meaning of this sigma or summation fi, it means you need to sum from f1 if you have f1, and then f2 plus f3 until the final frequency. Okay, so in this case, what do you have? In this case, you have 1. So the f1 is 1, right? Can you see?
Yeah.
And then your 2 is f2, 4 is your f3, 2, and then plus 1. So your summation of fi in this case is just this. So you just sum up the frequency. So you get what? 3 plus 4, 7, so it's 10. So your denominator is 10. So this is found. So I don't need to read it anymore. Okay, now, can you see that? What is the meaning of this? Mean, right?
Yeah.
Okay, so continue to find out the mean. How do you find out the mean? The mean is nothing but you just write down this fx first. So this is 1 times 1 is 1, 2 times 2 is 4, 3 times 4 is 12, 8, and 5. So to find out the mean, you just have to add this, add all this up, and then divide by the frequency, the sum of frequency, right? So let me just add up this first. So 4 plus 12, 16. 16 plus 13, 29. So 29 over summation of 10. I mean, summation of frequency. So the mean is actually 2.9. Okay, so this is the mean. All right. So I have found out the mean already.
Right.
So this is done. So what you do next is pretty simple. So you have to find out your this f1 x1 minus, okay, the mean, which is 2.9, square it, plus what? Plus your f2 x2 minus 2.9, square it. Am I right?
Yeah.
Until your fn. All right.
Yeah.
Okay. So let me continue to do it with this table. So the first thing I will do is I will find out what is the x minus 2.9.
Okay.
And square. So your x is 1 here, right?
Yeah.
The mean is 2.9, right? So you have minus 1.9, square it. Do you have a calculator with you? Just beside you?
Yes.
Can you just help me out? Can you help me out with the value of square? Just minus 1.9 bracket square. So what do you get?
Wait, wait, 1.9, 3.61.
Okay, 3.61. So subsequently is 2 minus 2.9, which is minus 0.9 square.
Yeah.
So what is, so it's 0.81.
0.81, yes.
So next is 3 minus 2.9 is 0.1 square, which is 0.01. Am I right?
Yeah.
So 4 minus this is 1.1 square is 1.21. All right. Then
Yeah.
5 minus 2.9 is 2.1. Square it. Can you help me out with 2.1? 2.1 times 2.1.
4.41.
Okay, 4.41. Okay, almost done. So now what you need to do is you just need to use this times this. So 1 times 3.61 is, so basically this is your this. All right, so this is 3.61. 2 times 0.81 is, what do you get? 16 or 1.62. Similarly, 4 times 0.01 is 0.04. 2 times this is 2.42. 1 times this is 4.41. So now, please help me out. Please help me out. Add all this together. And what do you get? Can you help me out? Use your calculator. By the way, is it big enough for you to see the numbers in blue?
Uh, 12.1.
12.1.
1.
All right. Okay. So that's it. So square root, basically your this standard deviation is 12.1 divided by 10. That will give you 1.21.
Yeah.
All right. Okay. So the formula looks intimidating, okay, at first glance, but if you follow it closely, you just have to do a lot of work, right? It takes a lot of effort, and it's not complicated. All right. So all you need to do is just follow this table. All right. Okay. So I have taught you how to find standard deviation for group data using the formula here, using this formula. Okay. Another way to do it is you can also use technology, either by Excel or your graphical calculator. All right.
Right.
Good. Let's move on. Okay, their answer is 1.1. Okay, our answer is 1.21, right?
Yeah.
How can it be 1.1? Oh, square root. I did not square root it. I'm so sorry. I need to square root. Okay, help me out. Square root 1.21. Oh, so that is about 1.1, yeah. All right.
Okay.
All right, so it's 1.1. Actually, yes, 1.1. Okay, so the standard deviation is 1.1. Let's see. Yeah, their answer is also 1.1. Pretty close, right? Their answer for the numerator is 12. Our answer is 12.1. Okay. Okay, next. You look at the way they do it. They also establish a table here. All right. Now, exercise. Okay, let's just take one example. Okay, what about 4? Okay. How do we do question 4? How do we do question 4? So we are not given a single value here, right?
Yeah.
We are given what? We are given a range. So how are we going to do this if we are given a range?
Put it as 41.
Yeah. So you take the mid value of the range, right? So what you have from this table is, so you can actually recreate the table. So you can actually use L here. So over here is your 41, 43, 45, 47, 49, 51, and 53. So you just take the mid value of the range. All right. Then after that, just focus from here onward. Because these two columns will be similar to the two columns we have just now, right?
Yeah.
Yeah. So from this, then you go ahead and find out the mean. and the standard deviation. Okay, you have to go through a lot of steps, like the step just now using the formula. All right, and that they ask you to estimate the mean and standard deviation of the population. So the mean for sample is denoted by this, okay, dash x. Standard deviation is SN, right? For the population, the symbol is different. The symbol for mean is mu for population. Standard deviation is what is it? Is rho, right?
Yeah.
So just take note of the difference between the symbols to represent mean and standard deviation for sample and your this population. All right. So I'm not going to go through this because it will take a lot of the time, but I will just make use of Excel. I will just make use of Excel to help me out. All right. Let me just get it here. Get this. Okay, I will recreate this. So 1. Wait. 47. Eh? Why I keep going to that? Yeah, good. All right. So the mean. So before I get the mean, I need to get this first. Just drag it. Sum of this. Good. So sum of this. Good. So the mean will be given by this. So this is the mean. All right. And standard deviation. So this is the standard deviation. All right. So I can actually make it just 2 decimal places. All right.
Right.
Okay. So the mean and standard deviation is given by this. All right. Let's move on. Yeah, similar questions here, right? So just take the mid value for the range and then create another table. All right. All right. So over here it talks about the significance of the standard deviation. Okay, we talk about it, right? So the significance of standard deviation is a better measure of dispersion of the data, right?
Right.
And over here talk about what mean minus 1 standard deviation, mean plus 1 standard deviation. So what it means is it's just 1 standard deviation away from the mean. Over here is 2 standard deviation away from the mean. Over here is 3 standard deviation away from the mean. And then these are the approximate percentage. I think you talked about this percentages in our previous lesson, right? So over here is the percentage, all right? Approximate percentage. Okay, if you look at this question, so example 14. So you have a sample of 200 boxes, so from a manufacturer, and the contents of each box measured for the weight, for the net weight. The sample mean is 486. And the standard deviation is 6.2. So that means the mean is 468. And in the standard deviation, one standard deviation away from it is, I think it's better for me to use Excel because I need to do a lot of calculation, plus and minus. All right, so just get rid of this part. How do I get rid of this? Okay, let me just get rid of it. Done. So this is 486, the mean. And then this is 1 standard deviation, 2 standard deviation, 3 standard deviation. This is -1 standard deviation. This is -2. This is -3 standard deviation. All right. So 1 standard deviation is 6.2. All right. So times this 6.2. Then let me just. All right. So continue. So this is 2 standard deviation away. Similarly, let me just. So this is 3 standard deviation. Very good. All right. So let me figure out the plus. Yes. All right. You know what I'm doing here, right?
Yeah.
Good. So, okay, I'm just finding out. So this will be the thing you should look at, right? The rest is just whatever I've done here is just for me to find out the one standard deviation away, 2 standard deviation away, and 3 standard deviation away, right? What's the value?
Yeah.
Okay. So the one you should look at is the one highlighted in yellow. All right. Okay.
Yeah.
So with this, and let's look at what the question is asking. Okay, what proportion of the boxes are expected to weigh between 479, which is here, to this? That means they are asking for 1 standard deviation away. Okay, so it's approximately 69.7%, right? What did they say? Over here. Over here. Yep, over here. So 1 standard deviation away is about 68%. So this is your 1 standard deviation away. All right, which is your question A. Right? How many boxes in the sample are expected to be in this weight range? So how many boxes? So 68%, right? So 68% times 200, right? So that is 60%, 68%, so 68% times 200. So it's about 136 boxes, all right, for this question. Okay? Easy, right?
Yeah. Well, no. For you.
Next. So the normal curve, okay, the normal curve. So if I were to make use of this curve to plot for the question just now, so it will look something like this. So let me just make use of this. All right. So if I were to use this to illustrate. All right. So over here, the mean will be 486. And the first standard deviation will be 492.2. And over here is 479.8. All right. And then the second deviation away is somewhere here. So the distance, right? The distance is about the same. So let me assume that your second standard deviation is here. The second standard deviation is here. Okay. So this will be your 473.6. This will be your 498.4. Of course, the third standard deviation will be like somewhere here. All right. So the third standard deviation is somewhere here. So this will be your 467.4. This will be your 504.6. All right.
Yeah.
So this is your the normal curve to represent this question. All right. Pretty simple, right?
Yeah.
Yeah. So it says in practice, it's rare to find data outside of 3 standard deviation, because outside 3 standard deviation means it is beyond 99.7%. So you are just looking at the 0.3% of the population. That is the very small number of people, right?
Right.
Yeah. So that's why it's very rare to go beyond the 3 standard deviation. All right. Okay, so now let me just pass question 1 to you, and let's see if you can create a normal curve or answer the question A, B, C, D. Can you do a screen capture of question 1?
Okay.
Okay, then I will stop sharing, and you start to share and see how you can answer this 1A, B, and C, and D. Okay, time for you to share. Is it very crowded in the driving center?
Yes, right now.
Wait, are they open on Sunday?
No.
Oh, okay. Okay, time for you to share your screen and see how you can solve a question, this question 1.
Okay. Yes.
Nice.
Deviation.
So to do this, I think it's good to establish your 1 standard deviation, 2 standard deviation, and 3 standard deviation. Both are left and right?
Yeah.
From the mean, yeah.
So
the mean is 184.
184. So it's 5, so it's 179. And 189. 190. All right, 190 something.
Oh, Real Madrid is doing well. I just saw you are wearing a Real Madrid shirt.
You know who else is not doing well? Arsenal.
Arsenal. Arsenal. They always don't do well.
No, I mean, like, I am excited because it is the derby tonight.
So they will play against Chelsea.
No, they play against Tottenham.
Oh, okay.
The sports.
Okay.
So I am excited, but you know, I'm afraid we're gonna get shit on.
When is the Barcelona versus Real Madrid game?
Let me check. El Clásico.
Yeah.
I mean, it's not really that fun.
Because I know they have. I think both teams have 2 games left, and they have 4 points apart, right? Or 3 games left. The two of them are pretty close.
I mean, like 2 more games. If Real don't like mess up 2 more games, and it's like it's over, right?
Yeah, you are right. But I think there is one more Classical plus 1 more game.
Yeah.
Is there?
Check.
Oh, surprisingly, there is no more.
Yeah, there's no more.
There's no more. Yeah.
There's no more.
Okay. Yeah.
So there's 3 against 3 pretty shitty teams, except Villarreal.
Okay.
Yeah, except Villarreal. The rest is like pretty shit.
Yeah. Okay. 2 more games, and they are 4 points apart. All right.
I mean, it's like Real Madrid. They have like a 4-point lead,
Yes.
so they only have to like win 1, draw 1, right?
Mm-hmm.
And you know they have. I think they have.
I mean, Barcelona cannot slip up again. They can't lose.
They have 2 games. They have 3 games left. They only have to win 2. Win this game, and it's pretty much over. Win this game, win the next game, and then it's over.
Yes.
Good.
If Real Madrid win 1 more game, it doesn't matter what Barcelona is going to do.
No, great. Yeah. Well, they're not gonna. They might lose to Villarreal. So if they win against the 2 shitty teams, then it's over.
Are you saying they have 3 games left?
Yeah, they have 3 games left.
So both teams have 3 games left?
No, Barca have 2 games left.
Oh, okay. Okay, back to this question.
The Barca have like 2 really shit teams left.
Oh, okay.
Also, Arsenal. We're playing the Spurs tonight.
Surprisingly, the Champions League is still ongoing. My goodness.
You know what's going on? Tonight, we play Tottenham. The next match, we play Liverpool.
Wow.
The next match, we play Man City.
Oh, wow. Is it going to be a losing streak?
And then we play against Aston Villa,
which
is relegated. And then we play Watford, which is about to get relegated.
Okay.
So it's all right.
Do you want it to be a losing streak?
Yeah, it's very possible. We're, I think, up 1 point up the Spurs. So it's pretty tough right now.
Yeah.
If they win against us, like we have no chance of getting in the getting in the European League.
Are you sharing your Excel? I'm afraid not.
Yeah, I'm sharing.
So are you
sharing right now? Yeah, I'm sharing.
Now you are. Yes. Okay.
Yeah, so it's not looking good.
No.
Let's check the Premier League shooter. Oh. Top scores. There's that.
So to answer 1A, taller than 189. So taller than 189 will be?
Yeah. And also, Jamie Vardy, number 1 top scorer.
How many goals?
22.
Oh, that's good.
That is good.
No, he should be. I mean, he should transfer to a bigger club, man.
I mean, no, but like he's old, you know. That's
How old
it.
is he?
It's hard for him to play in a bigger club.
No, how old is he?
He's like 34.
I mean, he's pretty alright. I mean, he can go to Arsenal and play for 2 seasons, and he can guarantee like 40 goals in 2 seasons.
But like we don't play counter-attacking football. So that's a shame.
But
And also Aubameyang has 20.
Aubameyang is 20.
Yes.
Wait, how old is Aubameyang?
Aubameyang is 31. So you really know how much he's carrying this team.
And by the way, you know Arsenal used to get rid of players above 30 years old.
Yeah. No,
What
they
happened?
don't get rid of players above 30 years old. You're above 30-year-olds, they sign your contract one by year. So they give you a 1-year contract.
Oh, that's okay. All right.
They don't like they push you out, but they give you a 1-year contract. So you feel disrespected and you will leave yourself.
Was that Wenger's idea?
No, it was the board's idea.
Oh, all right.
I think it was a strategy to get rid of Pire.
Oh, okay. All right. Yep. So back to this question. How do you answer this question? 1A.
Okay, so 5 centimeters, right? Taller than 189. This is 2.
So what will be the percentage?
Wait, check.
So the first one is 68%.
Curve. Normal curve. Distribution. There it is.
Oh, nice.
Isn't that
The second one looks good.
this guy?
Yeah.
Okay, 34.
You have the percentage. So you just copy and paste it here, so you don't have to refer to this anymore.
Mm. Five. The 2.35. Okay, something like this. It does. Okay. Taller than 189. So taller than. So it's
Wait, I think you also need to account for the 0.15% beyond the 3 standard deviation.
so what was it? 204. This is what is it? 161.
Are you talking about 4 standard deviation?
Okay, like this.
Mm.
So 189. 189 is 34. So 13. 13.5.
Yeah, you just add the 3 up, right?
Yeah, 13.
You can make use of Excel here. Just add them up.
Right.
You just add the cell up. Yep, sum, then just.
Right, yeah. Why didn't I think of that? Sum. Okay. The taller than 160.
179.
179. So it's there.
Yep. So the sum this.
Equals sum. Here. Then between 164 and 199. So it's 164. So it's like this, 199. So it's like this. Um, D. Over 1. Okay, so it's 0.14.
Yep. All right. So yeah, that's the way to. So this is the way to do the question. Yeah. Pretty easy. We use the Excel, right? All right. Let's back to this PDF. Okay, we are at review set 14A. Yeah. So over here you have all the data set here, and you are asked to produce a stem plot for this data. Can you still remember the stem plot?
Well, which one?
Stem
I
and
can't
leaf.
see.
The stem and
Oh,
leaf.
yeah.
All right.
Yeah.
So stem plot is a stem and leaf diagram.
Yeah.
All right. Okay. So and you are asked to find the mean, the median, and range of the data and comment on the skewness of the data. All right. So let me just pick this and just pretty fast. We are already at a review. So I will continue to use my use Excel. Okay. The beauty of using Excel is really for the manipulation of data. Right. So just key in the data. I will rearrange it later on. All right, that's good. So this is for index, and this is for value. Right. Okay, so now what I'm going to do is I'm going to produce a stem plot. Let me try to create a stem plot. Hey, no, I don't want to create here. Let me create it. Let me create it just here. Let me create it here. All right, so this will be my values rows. Yes. Then I'm going to do count. No, I don't want sum. I want count. Yeah, so this is the stem plot.
Yeah.
Or rather, I think the stem plot is this. Stem and leaf. So 0.4, right? So you have 1, right? So
yeah.
0. So that's it. So 0.8. How should I put this? Okay, 1.1, 1.2. Oh, okay, I get it. So 0. Then I have 4. Then I have 8. I have 9. Okay, then let me just move this away. And if I have 1, then I have 3, I have 5, I have 2, 5, and then I have 1, 7. Good. And then I have 2, 1. Okay. And I have 1, 5, 6. 8, and 8, then 3, then 0, 0.1, 0.2, 0.3, 0.4. I have 2, 5, 3, 2, 6. So let me see, 2, 7, 2, 7, and 1, 9. Okay, let me just move this away again. Make it smaller. So 2, 7, and 1, 9. So 4. So I have 1, 4, and then I have 4.2, 1, 4, then 7. Okay, that's it. Yep, this is the one. So this is the stem and leaf diagram. All right. So how do you read this? Is this one is 0.4, okay? This and this and this is 0.8, and this is 0.9. All right, that's how you read this stem and leaf diagram. All right. Can you see the stem and leaf diagram here?
Yeah.
So what I need to what I do is I'm trying to see how many 0.4 I have, and the count is just 1, and then the 1.5 there 2 counts of 1.5. So you can see at 1 I have 2 1.5 here, right? And you have 2.8, you have 2 counts as well. So I have 2.8 here. All right. Okay. Yep. So I'm done with this stem plot. So now I'm asked to find the median. All right. So to find the median is pretty simple. I have 30 data here, right? So the median should be, so 30 is what? 30 is 14, and then the 15 and the 16, right? The 15 and the 16, and you have to add them up and divide by 2, right? So how you split 30? Let me just make it smaller. So you have 30 data here. So you split it 14 and then 14, and in between you have the 15 and 16, which you have to add and then divide by 2 to find the median, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 here. Which means I have to take 3.1 plus 3.2 and divide by 2, and that's 3.15. So this is the median, right?
Yeah.
And the range of the data, pretty simple. Range is given by, can you remember the formula? Max minus the minimum.
Minimum. Yeah.
So the max here is 4.9, and the minimum is 0.4. So that will be 4.5. All right. And comment on the skewness of the data. All right. So I think this set of data is skewed towards the higher number. Can you see you have a lot of numbers in the range of 3 to 4, right? So it's kind of like skewed towards the, I'm sorry. So let me just erase this. So it's skewed towards the higher number. Can you see? So basically this can actually help you see the effect of the skewness of the data. Okay, can you see? Over here is pretty low and then shoot up until the, okay, and then it comes down. So it's basically like this. All right, something like this. All right,
Right.
so it's skewed towards the higher end of the data. All right, so if you are asked to find the standard deviation, right? So you can actually use the Excel here, but which you are not. So comment on the skewness. So it's skewed towards the higher end of the data set. All right. In this case, it's 3 and 4. All right. Okay, let's continue. This is the stem plot. All right.
Yeah.
So over here you read 32.1. Okay. And then all right. So that means over here they give you in all these format unarranged data. So you use a stem and leaf diagram to make sure you convert the data into arranged format, which is this. So then you can actually find out your this shape, median, and range. All right. So we're not going to do that. Okay. Let's look at this. Okay. Question 6. Our cumulative frequency diagram. So over here it says 80 senior students needed to run 400 meters. All right. And over here the time taken is recorded. Okay. And you have this cumulative frequency. And what's the median? The median is here, right? 40.
Yeah.
Then you just read here. So this will be, how many units here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 in 10 units. Right? So 1 unit is 0.5, right? So 10 unit is 5. So 10 unit is 5. So 1 unit is 0.5, right? All right. So
Yeah.
over here is how many units? 1, 2, 3, 4, 5, 6, 7. 7, yes, yeah. So 7U is 3.5. So 55 plus 3.5, this will be your 58.5. So that's the median. The unit is seconds. Interquartile range. So first find out the lower quartile range first. So the lower quartile for 80 is, the lower quartile for 80 is 80 times 1/4. That will be 20. So the upper quartile is 80 times 3/4. That will be 60. Right. So over here is this. So this will be 55.5. And here, 60 here. So 3 unit will be 1.5. So it's 61. Okay. So your interquartile range is 61.5 minus 55. That will give you 6. This is called interquartile range. All right. Yeah. So that's your interquartile range. So that's 6 seconds. All right. Pretty simple, right?
Yeah.
Let's move on. All right. So I will pass question 8 to you. Okay. Please take a screenshot of question 8. So I pass question 8 to you. Question 8 here.
Okay, done.
Have you taken a screenshot?
Yes.
Okay, so I will stop sharing and let's share how you can solve question 8.
Okay, tops at 200.
So please share your Excel or whichever you use to solve.
Okay.
It's good to do it in Excel. Yeah, you can calculate using Excel.
If 30%.
Oh no, question A first. You can make it smaller.
Yeah,
so
yeah.
you can cover.
How many students spend between 10 to 20 minutes? 10 to 20 minutes to travel to school. So is that 20?
Yep, it's 20 for 10. Yes.
And what is that?
You can insert a cross on the diagram to just have
104, 105, 105. Like 20 to 105. It's like 85. %30 of the students. More than 30% of students more than n minutes. 30% is 60. So that's 140. 140. More than n minutes. 30%. So 140. 140 goes down.
Yeah, you're right.
So it's 24 minutes.
Yes. All right. So that's the way.
Yeah. 4.
Yeah.
Yes.
Yeah. That's the way to do it. All right. So review set B, similar stuff, but you are asked to find more things. Over here, you deal with more things like median, mean and standard deviation, and interquartile range. All right. So once again, over here, can you see the data is given in a range, right? 0 to 9.9. So your job is to figure out the mean value and create another table. All right.
Yeah.
So let me just pick one, and we will look at. Let's pick one. I will pick this. This one. The winning margin, then the results represent, draw a column graph to represent this component. The mean and standard deviation of normal deviation. What about? Yeah, let me just pick this. Okay, it says the winning margin, okay, was recorded. So points. Oh, you no longer watch basketball, right?
I don't.
Okay. All right. The results are given alongside here. Draw a column graph to represent this information. So what you can do here is let me get it into not Excel. Let me get this into where's my mouse? Oh, here. Let me get it to this. Yep, I'm going to do it here. And let me just. I just need this much also. All right. Make it smaller. All right, good. So I'm going to draw a column graph. So let me start with this. Pretty good. And I have 1 to 50. So yep, should be good. So let me just make sure this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another 10. So this is your 0, 10, 20, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30, 2, 4, 6, 8, 10, 40, 2, 4, 6, 8, 10, 15. That's for the horizontal. This will be the margin points. Margin points. And you have we have these numbers. So I think it's good to go with 10 and 20 and 30. Yes. So maximum 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here. 20. Sorry.
Okay.
40. All right. So this is your frequency axis. Okay. I'm not drawing a cumulative frequency. I'm just drawing the column. So what you need to do now is quite simple. Just insert shape. How do we? Okay, this is the shape. Yeah. So 1 to 10, 13. So 1 to 10, 13. So just go to 13, 11, 12, 13 here. Okay. And the next one will be 35. So just get this. So this is 1, 2, 3. Yeah. So this will be 35. 2, 3, 4, 5.
Right.
All right. 27. So come down. So this is 20. 1, 2, 3, 4, 5, 6, 7. See here. And 18. Okay. Let me just pop it side by side. So I'm going to take 18. So this is 10. So it's 2, 4, 6, 8, 18. Last 7. So this is 2, 4, 6, 7. Yeah, somewhere. All right. So this is the column graph to represent this information. All right.
Yeah.
Okay. So pretty easy. Yeah. Okay. And it says that this question too is very relevant to what we have learned today. Okay. So the mean and standard deviation. Let me just grab this out. Okay. The new concept we learned today is the 1 standard deviation, 2 standard deviation, and 3 standard deviation away from the mean, right? So let me do it here. Okay, so this is your mean, and 12 is the standard deviation, right? Okay, so this is 1, 2, 3. This is -1. This is 2 standard deviation, then minus 3 standard deviation. Yep. Good to go. So equal 3 times 12. So F4. Then all I need to do is drag it. So all I need to do is paste it, copy, paste. So yeah, good enough. So 150 here, and this will be this plus it. So sorry, equal this plus this. Let's drag it. Similarly for the right hand side. All right, so this is the one you should be looking at. All right, so if you were to draw the standard deviation out, so I will just make use of like what you did just now. Just use Google. Normal distribution curve, right? Yeah, we'll just make use of this. I will just make use of this. And then here we are. Okay. I just replace it with the values I have here. So this is the 150 is here, right? And 162 is here. 138 and 126. This is 114. Oh, I don't seem to be able to write on it. Let me see. Let me send it to the back. Okay, good. So this is 126. This is 114. Over here, 174. Over here, 186. All right, so now I can actually solve. So it says the percentage 138, 162. 138 is here. 162 is here. So between is 68.2%. Right?
Right. Yeah.
126 to 174. So they're asking for this 95.4%. This range. 126 to 126 to 16. Oops. 126 to 162. So which is here. To here. Right? So you just have to add up what? You just have to add up 60, add up all this. This should be 6. Right? Which is here, here, and here. Right? So that is 68.2 plus 13.6. That will give you 0.8% and 81.8%. Last 162 here. 2, 174. 13.6%. Pretty easy, right? All right. So it's very good to have this. Okay, it's very good to have this. Just make use of this and just read from this graph. Replace your mean and one standard deviation with values. So everything is very clear from here onwards. All right. Okay. Last question. Question 7. Is a big question. So let's get it out. get it out. Take note. Let's go to this. Okay, let's look at the question together. Make it smaller. Good. Is it big enough for you to see? I hope so. Okay, good. First question. Oh, I can actually make it bigger. Okay, all right. An examination worth 100 marks was given to 800 biology students. The cumulative frequency graph for the below is shown. Find the number of students who scored 85 marks or less. So where's 85 marks? So this is 85 marks. Okay, 85 is here. So it's here, right? So just read this across. So I'm going to use a line, right? So 150, so it's in between 100 and 150, right? So this is 150. So it's in between, all right? I will take it as 125 because this is your 45 marks, right? Less, so I will take this as 125. So for number of students score less, so 125. All right, students. Okay, find the median score. So 800 median is, so this is your median, 50% 50% position. So just read it across. Let me use kind of like I can use a ruler here. So okay, it's slightly more than slightly more than 65, slightly more than 65. So I will take 66. So I actually doing I'm using estimation. I'm estimating, okay, because it's slightly less than 65 and slightly more than 65. So I just take it as 66. All right. So between what values do the middle 50% of test result lie? So between what values do the middle 50% of the test result lie? So 100 marks is the total marks. So 50% test results. What's the meaning of it?
So it's the median.
Wait, I thought I found the median score.
Yeah, all right.
So it says between what values do the middle 50% of test results lie?
So it's like 45 and is it 4? No. It's 800.
Okay, middle 50% of test results. Okay,
Is it
total
range?
100, right? So 50% of test result. So basically what it means is your 50% of the test result. So that means 400 students is the 50% result, right? So it's in between where to where. So it's in between here, right? 60 and 70, right? Of course, you can also say from 65 to 70, right? All right.
Mm-hmm.
or rather 400 students. So the 400 students, it starts from 0 mark to 66 marks. All right. Hold on, let me admit my student and I said, let me talk to my student. Okay.
Okay.
Hello, is Shamin? Is Shamin? Hey, Shamina, I'm having the last few minutes of my lesson with the other student. So I will just mute you. Okay, good. All right, so yeah, so over here, the range is actually 0 to 66. So 50% of the student lie between 0 to 66. Okay? That means here. All right? Now, find the interquartile range. Okay, so find out your this 800, 1/4 of it is 200, so this is here. So this will be slightly less than 55. I will take 54, which is your lower quartile. Upper quartile is 600, right? So it's here. So this is quite clear. It's 75. So 75 minus 54. That is 21. So that's the interquartile range. What percentage of students obtain a mark of 55 or more? So just go to 55. 55 is here. 55 is here, so it's this. So I will read here. If this is 250, I will take 210. So 210, total is 800. So 800 minus 210, that will give you 590 over 800. That is the percentage. All right.
Right.
If a distinction is awarded to the top 10%, all right. So top 10%, that means only 80 students get to score that, right? Because you have 800. Yeah. So 80 students. So just find out where is the 80 students. So this is your 750. 80 will be somewhere here. So the score is about 80. I will take 82. All right.
Yeah.
Yeah. So that's how you read the cumulative frequency diagram and solve this question. All right. So I hope you are clear about this chapter on statistics. Okay.
Yeah.
Yeah. So see you next week, and we will have we will move on to the next chapter. All right.
Okay.
All right. Bye bye. Take care.
Bye.